Hello and welcome to the video. This is part 2 of my 3-part series to go over memorization tips and tricks for amino acids. If you haven't seen part 1, make sure you check it out because I go over some terminology and things you'll need to know to understand this video, as well as the structures for some amino acids. Alright, now that we're caught up, let's meet an amino acid. Today we're starting with cysteine. It corresponds with the letter C of the alphabet. The 3-letter abbreviation for this one is going to be CYS, the first 3 letters of its name. The R group is going to be a carbon with a sulfur attached. And the trick to remember it is that the name cysteine has 2 S sounds. And because it has a lot of S sounds, it has a sulfur, which is represented by an S. A pretty easy amino acid to start out with. Now let's move on to another easy one. This is serine. It corresponds to the letter S, and its 3-letter abbreviation is SER. The structure for this amino acid is a carbon with an OH group attached. And at this point you may be thinking, now hang on a second, isn't serine's R group just like cysteine's R group, except that it has an OH group instead of a sulfur? Also, wouldn't it be easier to memorize if their names were switched so that the one whose name starts with S has the sulfur in its R group? To which I would say, wow, that is a very astute observation and a logical train of thought. Unfortunately, many of the scientists of the past don't seem to have been thinking very logically when they named things, so we have to deal with cysteine being the one with the sulfur and serine instead having the OH group. To remember this infuriating fact, notice that serine only has one S sound in its name, and so is the one with the OH group instead of the sulfur. Or you could remember how annoying the whole situation is and memorize it based on your internal rage. Go ahead and pause the video and take a moment to calm down if you need it. And once you're ready, go ahead and restart and we will move on. This is threonine, and it corresponds to the letter T, and the 3-letter abbreviation is THR. Threonine has a 2-carbon chain with an OH group attached to the first carbon of its R group. Now, another important thing to note is that this is an example of what I mentioned in part 1, namely that if there are 2 amino acids with similar structures, the one that occurs later alphabetically will have more carbons in its structure. We can see this when we compare serine to threonine because they have similar structures, specifically carbon or carbons with an OH attached, and they correspond to S and then T alphabetically, and so since threonine comes later alphabetically, it has one more carbon in its structure. The trick to remembering threonine is that if you imagine that there was something else attached to that first carbon, it would make a T shape, like I've drawn here. Alright, now let's move on to another structure that will include something that may be new to a lot of you, a ring. This is tyrosine, and it corresponds to the letter Y. Sorry, T was already taken, but at least there's a Y in the name. The 3-letter abbreviation is TYR. Its structure has a carbon attached to a ring of double-bonded carbons called a benzene ring, or sometimes a phenyl group, and attached to that is an OH group. The trick to remember this one is that tyrosine begins with tire, and since tires are round, you can remember that it has a benzene ring and an OH group. Now, one more quick note for this one is that there is a shorthand way to draw this ring so you don't have to write out all the carbons, and it is like I have just done. Then, to denote that all the carbons in the ring are double bonded, you can just draw a circle inside of the hexagonal ring. Alright, let's go ahead and move on. Okay, so I'm introducing these two together because they are a pain, but in a way that is related to each other, and that helps me remember the structures. Okay, so let's start with the one on the upper left. This is isoleucine, and it corresponds to the letter I, But instead of having the first 3 letters be the abbreviation, isoleucine's abbreviation is ILE. I know, right? I think they did it this way to connect it to leucine, which is part of its name, and leucine's 3-letter abbreviation is LEU. Whatever the reason, that is one of the reasons these two are annoying. Real quick, before we move on to structures, I just want to point out that leucine corresponds to the letter L. Alright, now let's get into the structures. Isoleucine has a 3-carbon chain with a single carbon attached to the first carbon of its R group. Because of this, its structure looks very much like a capital L, which is annoying because isoleucine does not begin with an L, it begins with an I. And the annoyance with this mismatch is how I remember isoleucine's structure. Leucine, on the other hand, has a 3-carbon chain with a single carbon attached to the second carbon of its R group, which is annoying because it doesn't seem to make an L shape at all. But if I draw some lines like this, then you can see that there are actually 2 L's, so at least one can be finagled into having a reasonable way to remember it. Alright, we're almost there, so let's keep moving. I know, it's another ring, but this is a bit easier. This is phenylalanine, which is just a mouthful for a name. It corresponds to the letter F, and its 3-letter abbreviation is PHE. Well, phenylalanine doesn't have an F in its name, but it does start with a F sound because of the PH. So it sort of starts with an F, if you pretend. As for the structure, its R group is 1 carbon with 1 phenyl attached, and actually the name tells us this because it's phenyl and alanine, and if you remember, alanine is the amino acid with just a carbon for its R group. Alright, just one last quick one and then we will be done. Methionine corresponds to the letter M, and its 3-letter abbreviation is MET. The structure has 2 carbons, then a sulfur followed by another carbon. The way to remember this is that alphabetically it comes after cysteine and has a similar structure to it. So methionine has at least 1 more carbon than cysteine. Then you just have to remember that the 2 carbons make a carbon sandwich of the sulfur. Well, that's all I have for this video. I hope you found it helpful and keep an eye out for part 3. Thanks for watching and have a great day.